Projectile problem is a ball is projected from the ground with a speed of 20 meters per second at an angle of 30 degrees to the horizontal. Find 1. Time of flight. 2. Maximum height. 3. Horizontal range. Take gravity, that acceleration due to gravity, to be 10 meters per second squared. So here is our solution to the problem. I want you to know that whenever you come across projectile is not one motion, it is two. We have the vertical motion. When you throw a ball, for example, we have two components, the vertical component and the horizontal component. Now this is suspended at an angle, let's say from our question, and at an angle of 30 degrees. 30 degrees. Now to understand this problem, we are going to reconstruct it into a right angle triangle. This is the speed of the ball. This is the speed of the ball, and this is the velocity. So we're going to have this to retain what is here. Now this is y, uy for the y component, and this is x. We have ux for the x component, and this is 30 degrees, the same angle suspended, 30 degrees, and this is the velocity of the ball. So this is the velocity of the ball. Now the velocity, it is important to know that the horizontal velocity is constant according to Newton's laws, because there is no horizontal force. The only force here, as you can see, is the vertical force, because when you project a ball, it goes against gravity. So it is a vertical force that changes, which is suspended at this angle, but the horizontal velocity is constant, but the vertical velocity changes. It changes because the force is only vertical. Here there's no force. All right, looking at this, let's start from uy. From trigonometry relationship, uy over u equals sine 30 degrees. So we'll have uy divided by u equals sine 30. Now that means that we're going to have uy equals u times sine 30. To make uy subject, multiply, we're going to have u sine 30. Now from our question, u is what? U is 20 meters per second, because u is the speed of the ball, 20 meters per second. So we're going to have 20, which is u, sine 30. So our uy, u sub y, equals, now sine 30 is 0.5, 20 times 0.5, and that is, we're going to have 10 meters per second for our uy. Similarly, for our ux, this is the horizontal component. From here, trigonometry relationship, ux over u is cos. So ux over u is cos 30 degrees. Cos 30 degrees. So cross and multiply to make ux subject to the formula. We're going to have ux equals u cos 30 degrees. Now u from our question is 20 meters per second. So we're going to have 20 cos 30 degrees. Now our ux, therefore, ux equals 20 times cos 30 is 0.8660. So we're going to have, as a result, 17.32 meter per second. So therefore we can say that our uy is 10 meter per second and our ux is 17.32 meter per second. So we go back to the problem. Since we have found the vertical component and the horizontal component, because it is two components, it is two direction we are looking at, the vertical and the horizontal. Now come back to the question, time of flight. Now it has a formula. The time of flight is given by 2 times the vertical velocity divided by acceleration due to gravity. It moves upwards, and as it moves upwards, the motion is vertical. So the time of flight will be dependent on this vertical motion, uy. So t is equals 2 times uy is 10 meter per second. So we're going to have 2 times 10 divided by acceleration due to gravity. So we're going to have 0 cancels 0. We're going to have 2 seconds. So this is our total time of flight. Now the next one we are asked to find is the maximum height. Now the maximum height has a formula too. The height is equals to u squared, that is the vertical velocity squared. The vertical velocity squared, u squared over g. The reason is still the same. In the projectile motion, the basic angle we are looking at is the vertical. The basic direction we are looking at is the vertical. We are not going to look at this one unless we are dealing with something like the range, because the range is defined as the horizontal distance from this point to this point. But the time of flight is dependent on this. The maximum height is dependent here, and more specifically, this is the height, the maximum height. So we're going to have u squared, uy squared over g. This is the formula, equals our uy squared. Our uy is 10 meter per second. So we're going to have 10 squared over 10. Remember, we're taking gravity, we're still taking gravity as 10. So we're going to have 10 squared is 100 over 10, 0 cancels 0. So the maximum height is given by 10 meters. Now the third problem we are asked to find is the horizontal range. Now the horizontal range, the formula is defined by r for the range equals to the total horizontal velocity, which is constant because there is no horizontal force by Newton's laws. Total horizontal velocity times total time will give us the distance from here to here. So we're going to have total horizontal velocity times total time will give us the total distance. So ux is we're going to have ux as 17.32 meter per second. So 17.32 meter per second times 2, which is the total time. So the horizontal distance, we're going to have 34.64 meters. So we have solved for time of flight, we have solved for maximum height and horizontal range. If you like content like this, please like and subscribe. Tell me what you think about this video, if this problem is quite understood. In case you see similar problems like this, you'll be able to tackle it with, by yourself with confidence. Share this video to those who need it and leave your comments on the comment section below. Thank you.